Hello, 6th Gold students, and welcome to your video on volume of cylinders. So what we have here on my desk is a circle. I'd like to give a special shout out to periods 4, 5, and 6 for cutting out these circles for me yesterday for today's lesson. So you know a circle is a two-dimensional object because when you look at that shape, it lays flat on the desk. So flat shapes, two-dimensional objects. So what happens when you take a circle and cut out a ton of them and stack them one on top of the next? Well, if you look over here at my little stack that periods 4, 5, and 6 made possible, here I have a stack of circles. I can't tell you how many this is, but it's pretty many. We cut out a lot yesterday. Do you see now by stacking circles one on top of the next that are all the exact same size, meaning they have the same radius, do you see how it makes a cylinder? Doesn't that look almost like a soup can or a soda can or maybe a candle? Some of the things that we talked about yesterday. So basically, the volume of a cylinder is simple. You take the area of the bottom. So if you would pick the cylinder up, actually, let me do that. If I pick the cylinder up, watch me here, moving the camera, pick the cylinder up and look at the bottom, you've got yourself a circle, right? So if you find the area of one of those circles, which we know the area of a circle is pi r squared. So if you take the area of one of those circles and then just multiply by how many circles you have, which essentially would be the tallness or the height, you should have your volume. How much space, right, is taken up here. So let me say that again. Any 3D object, right? If you take the 3D object, pick it up, look at the bottom, find the area of the bottom, and then multiply by how tall it is, because that's kind of like just adding all the areas up. Like you could sit here and say pi r squared plus pi r squared plus pi r squared plus pi r squared plus pi r squared all these times, but wouldn't that just be the same as taking the bottom one and multiplying by the height of the stack? Wouldn't the height of the stack be how many of these you have? So that's how you find volume of a cylinder. So let's just talk about that formula. So think to yourself, what is the formula for the area of one circle? Grab my pen here. I'm actually going to put my phone now on the holder so I can continue on with the notes. So one moment, please. These are very high-tech videos. Stop laughing. Okay. Okay, very high-tech. Okay, so the area of one circle, guys, is going to be area equals pi times radius squared. We learned that last week. If you recall, we learned that last week. And then for volume of the entire stack, the volume, let me write this down, V, is going to equal the area of the first circle on the bottom, pi r squared, times the height of the stack. And that's going to be the volume of a cylinder. So pretty cool. So that is the derivation, or where it comes from, why the formula is where it is. Now, you should have a worksheet in front of you that looks like this. Volume of a cylinder. And you're actually, I know a lot of times when we take notes, we don't, or when we watch a video splash, we don't take notes, but today we are going to take notes so that you're able to do your IXL successfully in just a few minutes. So here's the formula. I'm going to highlight it. We just talked about it. The formula for the volume of this cylinder, it's actually easier than the formula we did yesterday for surface area. So volume is pi r squared, which is the area of one circle, moved through the height. Okay, the y has already been answered. I said, let's cut out some circles, but I kind of took care of that yesterday. So we can get right into our examples. So the first example says, find the volume of the cylinder below. Use 3.14 for pi and round your answer to the nearest hundredth. So here we go. Let's start first by identifying, so step one, let's identify the radius and the height. So if you look here, our radius is from the center of the circle here, that is the bottom, out to the edge of the circle. So the radius will be 6 centimeters and the height will be 15. Step 2, let's set up the play with the formula for volume of a cylinder. It's going to be 3.14, which is your pi, times the radius squared times the height. Pi r squared h. And now the third and final step, let's actually put our specific measurements in. So it's going to be 3.14 times 6 to the second power times 15. And then we will grab our handy dandy calculator here and we'll put it in. So I'm going to turn my calculator on and I'm going to type in 3.14 times 6 raised to the second power times 15. You can see that there. And it looks like I'm getting 1,695.6, and then my units will be centimeters cubed since it's volume. 1695.6. 1695.6 cubic centimeters, and that's going to be our final answer. And that, my friends, is about as hard as it gets. But let's turn the worksheet over to the back. I think I have like 2 more examples. Okay, number 2. If you guys can see this, let me kind of zoom in a little bit more. Sorry for all the techie issues today. Okay, find the volume of the cylinder below. Same thing, use 3.14 for pi, round to the nearest hundredth. I think these are the same cylinders from the examples yesterday. Okay, step 1, let's identify the radius and the height. Now they're trying to trick you on this one. They give you the diameter of the base here, of this circle. And we know radius is going to only be half of that. So if you take 7 and divide it in half, you're going to get 3.5 for your radius. So my radius is 3.5. So I'll put that here. And then of course my height is right here, 14. So again, I'm going to find the area of this base and move it through the height. That's going to create that magical stack here for volume. And so step 2, let's write the formula, set up the play. Volume equals pi times radius squared times height. Volume equals 3.14 times 3.5 squared times 14. And I'm going to put that in my calculator. Just be super careful when you do that. Okay, so we have 3.14 times 3.5 squared times 14. 538.51. And again, that's already rounded to hundredths because the decimal only goes to the hundredths place. So we're safe there. 538.51. 538.51 cubic centimeters. Final answer. Okay, and last but not least, I kind of wrote over top of it, a cylinder has a height of 10 inches and a radius of 2 inches. What is the volume of the cylinder? So again, step 1, we'll identify the radius and the height. So the radius is right here, 2 inches. The height is 10. Step 2 is to set up the formula. Volume is 3.14 times r to the second power times h. Step 3, plug in our specific values. 3.14 times 2 squared times 10. This is almost easier than yesterday, I think. Okay, so clear that out. 3.14 times 2 squared times 10 pi r squared h. 125.6. 125.6 inches cubed. And that's it. It's as simple as that. So thanks for watching. I think you guys are going to do an IXL now called Volume of Cylinders in your recommendations. And you're going to get your SMART scores to 80 or hopefully even 100. And then after that, you're going to be doing a Schoology assessment for 10 points. This is going to take us back on a little bit of a journey back to even rectangular prisms, triangular prisms, some circle business, just to get us set up for Wednesday, because on Wednesday, we're going to start our project. Okay, good luck with all that, and I'll see you tomorrow.